So here we have the 2.6 homework, no, sorry, 2.7 homework. And I don't know, I don't think it'll be too bad. Number 2, I'm asking you to solve with the transitive property. Transitive property says if two things are equal to the same thing, then they are equal to each other. I don't know if I went over that in your notes or not, but it's a very useful property. Anyways, to use the transitive property, I'm going to have to move this guy over here. So 2y is equal to 3x, negative 3x squared plus 4. I'm going to divide out the 2. And I'll have y is negative 3 halves x squared plus 2. And now I notice that this equation right here is equal to y, as is this one. So these two pieces must be equal, and that is the transitive property. I'm going to go ahead and clear the fractions because I don't want to do the quadratic formula with a fraction. But what do I know about math? Absolutely nothing. So I'm going to 2 every single thing. Negative 2x minus 2 is equal to negative 3x squared because the 2's cancel here. And then plus 4. And then I'm going to one-side it. I'm going to actually shift everything left. That'll make this 3x squared positive. So 3x squared minus 2x, and then what, minus 6. And now I'm equal to nothing. I don't know if that one factors or not. I'm pretty sleepy this morning. So 3x and an x for 3x squared. Factors of 6 are going to be 2 and 3, or 6 and 1. Yeah, I don't believe it factors. So I guess I'll do some old x equals negative b plus or minus square root b squared minus 4ac all over 2a. So b is negative 2, so positive 2, plus or minus square root. Wrap, always wrap, especially if you're a button pusher. A is 3, c is negative 6. It's all over twice a, and a again was 3. So what's inside here? We have 4 times 3, which is 12, times 6, which is 72. And negative times negative is a positive. And then we have 4. And 4 plus 72 is 76. So 2 plus or minus root 76, both pieces over 6. I like to break it apart. Root 76 is divisible by 4. 76 should be root 4 times 19. So root 19, which is going to be 2 roots of 19. 2 over 6 is a third. And, let's think about this. 2 roots of 19 over 6. What does that reduce down to? Well, 2 over 6 is also a third. It's supposed to be a 19, sorry. So 1/3 plus or minus root 19 over third. And we are solving a system. So here's the fun part. These are x values. Got to have y values too. Kind of makes it a pain in the butt. Now, nobody would ever ask you anything this hard on the EOC. But, the difference between an okay student and a great student, the difference between a STEM major and a history major, why not knock on history, is that the STEM major can do this kind of stuff. So these are your x's. If I want y, I can just plug in. So y is negative x, or negative symbol, 1/3 plus root 19 over 3 minus 1. And the only things I can actually combine here is the negative 1/3 and negative 1, which is going to be negative 4/3. Now, negative times root times 19 is negative root 19 over 3. And we have a negative 1/3, take away 1, which is also a negative 4/3. There's one of the y values. The other y value happens when I plug in the minus root 19. negative 1/3 minus root 19 over 3, and then take away 1. I don't know why I had that extra set of parentheses there. So I'm going to have a positive root of 19 over 3 this time because I am using the distributive property. And I still have the negative 4/3. So here's my other y value as well. Now I have my ordered pairs. I had a third plus root 19 over 3, comma. The y value for that one was negative 4/3 minus root 19 over 3. One ordered pair. The other ordered pair happened when I did a third minus root 19 over 3. And I got a y value of negative 4/3 plus root 19 over 3. So, are you the STEM major or are you the art major? Which one are you? And I'm not knocking it, I'm just saying. Use substitution to solve the system of equations. These are basically also the transitive property. Hopefully they work out better than the last one. But let's take this equation right here and let's just solve it for y. So y is going to be 22 plus 19x. And then you can just put it right there. So 22 plus 19x is equal to 3x squared plus 7x minus 10. And I'm going to do a shift right because I want to keep 3x squared positive. 7 minus 19 is negative 12x. Negative 10 minus 22 is negative 32. That one stands a chance of factoring, I think. Let's see, 32 would be things like 2 and 16, or maybe 8 and 4. I was really hoping this would factor. I don't really care to do the quadratic formula over and over and over and over. I really don't. But I ain't seeing it. That stinks. Bummer. So x equals negative b plus or minus square root b squared minus 4ac all over 2a. All right, let's see what we got in here. We got a negative 12 squared, which is 144. We have a negative times a negative, so positive. We have 12 times 32. That's 384. It should be 528. We should probably check today. It's too early. The calculator won't turn on either. $528. Okay, cool. There's not anything you can do with that, really. I mean, it doesn't have a nice answer. So we're just going to simplify it. Let's see what she's divisible by. I'm sure I can divide it by 4. I can do better than 4, apparently. I know that because I got an even number. Maybe 16. Ah, there we go. 528 is root 16 times root 33, which is 4 root 33. So I have 12 plus or minus 4 roots of 33, both pieces over 6. 12 over 6 is 2, and 4 over 6 is 2/3. And I'm not gonna go back and plug in for y. It just, I'm not that concerned about your ability to do that. So anyways, there we go. 6 has a fraction. Might as well do it because it'll freak y'all out. And I guess this has a typo too, because that's say y equals, oops, that's what it should say. So might as well do it. But y here would be 1/2 x minus 5, and then you can just take that and put it right there. So 3x squared minus 2x plus 7 equals 1/2 of x minus 5. Again, I'm not a huge fan of the fractions, so I'm going to double everything. I'm going to clear the fraction, but what does the math teacher know? Apparently nothing. Just double everything, clear your fractions, and then throw everything on one side. And I will try to factor, even though it probably doesn't factor. I got this out of a Savas book. So I don't know. I really don't. I counteracted negativity with positivity and stuff like that. Let's see here. Let's try the 3x and 2x. 24 is going to be what? 4 and 6. There's no way 4 and 6 are going to work. Because like that would make 12 and 12. Or 18 and 8. So that's not going to happen. Maybe 2 and 12. That's not going to happen. Okay, I always have picked up a pencil and, you know, at least written this down just so it's less stuff I have to keep in my head. I may not place the numbers here. So 6x and x might be the other way to get 6x squared. I just don't feel it's going to factor. But let's see here. If I put a 6 here, I'd have 36. And then a 4, no. If I put a 4 here, I'd have 24, no. If I put a 12, a 2, no. So no, it doesn't factor. It'd been cool if it did. Anyways, x equals negative b plus or minus square root b squared minus 4ac all over 2a. And then we throw things at it. 5 plus or minus square root, always wrap, is 6. C is 24. Ah, okay, now I see why it didn't factor. Hopefully you see why it didn't factor. So what do we have in here? We have the root of 25. It's going to be 24 times 24, which is 500 something. 496, isn't it? 576. This is why it didn't factor. It didn't factor with a real number set. And I am not yet programmed to be also thinking about all the complex possibilities. And again, just making sure I didn't make any mistakes. It's easy to do. All right, so 25 minus 576 is going to be negative 551. It has no real solutions. Now, you should go ahead and, you know, make that imaginary. The imaginary root of 551 over 12. I'd be surprised if you could simplify 551. It's not divisible by 9. It's not going to be divisible by anything even because it's odd. So now it's the imaginary root of 551 over 12. No real answers. Let's go ahead and see what Desmos says just to make sure I didn't make any mistakes here. Desmos is a good way to check your work. 3x squared minus 2x plus 7. You got to have the y equals. And get comfortable with Desmos. You get to use Desmos on your end of course test. Now, we'll do things in this class like take benchmarks and stuff where I can't let you use Desmos because those platforms aren't locked down and you could do pretty much anything. The other one was y is 1/2 of x minus 5. Let's go on the hunt for this. Yeah, see, they never cross paths. So imaginary solutions. I am burning through time that I don't have. I still got to finish a twin for y'all. All right, solve the system of inequalities by shading. Use your calculator to find the vertex, the intersections, and clearly label them. Now, in order to use your TID4, you're going to have to, solve these things for y. So we'd move the 5 over. Let's leave the y on the right. We'd move the x over, x minus 5. And that one I can graph by hand. Rise one on one, right? And it is dashed. I can do that one. And it says y is bigger, so it's going to be shaded this way. All right. The other one's going to be a parabola. We know that. See, we have an x minus a 5. And we have a negative 3x squared. Plus a 6x. Plus a 1. Zoom 6. All right, let's talk about my parabola here. My parabola, if I let x be 0, has a y-intercept of 1. And you can kind of see that on there. You could do opposite b over 2a for your vertex. So opposite of a positive 6 is negative 6. Divided by twice a negative 3 is going to be 1. If you plug a 1 in, you're going to have negative 3 plus 6, which is 3, plus 1, which is 4. There's a second point. And symmetry will tell me there's a third point. Remember the axis of symmetry? So here's my parabola. Now I need to know the locations of the intersections. It's going to help with shading. I am less than, by the way, so all of this is going to be shaded. And what I'm interested in is the overlap space. I want to know the overlap space where both things are true. So this is why I need these x values for these intersections. So let's see here. We have second, trace, 5 for intersect. Get your cursor close and press enter 3 times. Enter, enter, enter. So there is an x value of 0.8081. That's your left boundary. Your right boundary is going to be right here. Things just don't want to work in the morning. There we go. Enter, enter, enter. And your right boundary is 2.4748. These are the x values that create this double shaded territory. So if I think about inequalities, I am stuck between negative 0.8081 and 2.4748. If I think about intervals, it's the same thing, just different notation. and intervals are usually easier to write. So there's 8. Moving forward, we got a little trig. An angle is drawn with the initial side being the positive x-axis and the terminal side intersecting at -3, -7. I know full well you guys are not taught all the trig there is. So an angle has its initial side as the positive x-axis. It means it starts here. And it rotates so that it's at -3, -7. You know, that's going to be in quadrant 3. We went back 3 to get to this point. And we went down 7. Notice what I'm doing? I'm drawing a triangle because I'm doing trigonometry. It says find the 6 trig ratios for this angle. Now, you get 3 of these trig ratios from SOHCAHTOA. It'll tell you that the sine of an angle, we don't know this angle, we'll just call it theta, is opposite over hypotenuse. I had one kid the other day said 0 over h. Like, how did you get your geometry credit? Cosine is adjacent over hypotenuse. The tangent of an angle is opposite over adjacent. And then you have the reciprocals. And the reciprocal of sine is called cosecant, and it would be a hoe. Sine says oh, cosecant is a hoe. The reciprocal of cosine is secant. Cosine says ah, secant is a funny guy that says ha. And the reciprocal of tangent is called cotangent. And if tangent is opposite over adjacent, then cotangent must be adjacent over opposite. So anyways, let's go through and find these things. Now to do the sine ratio, you're going to have to use that really ancient theorem called Pythagorean theorem, a squared plus b squared is c squared. And you're just going to plug your numbers in here. Remember to wrap negatives when you square because you're button pushers. And I don't know how to fix that. So a -3 squared is 9, 7 squared is 49, 9 and 49 makes 58. So c squared is 58, which means c is the square root of 58, which does not simplify. But there is my hypotenuse, and the angle, by the way, is always in the corner. So opposite of theta is a -7. The hypotenuse is root 58. You cannot have radicals in the denominator, so you multiply by root 58 over root 58, and you get -7 roots of 58 over 58. Cosecant's the hoe, flip right here. Flip this thing. That'd be negative root 58 over 7. Cosine is adjacent over hypotenuse, which is going to be a -3 over root 58. Same cleanup process. Root 58 both pieces. So we get -3 roots of 58 over 58. Flip cosine right here to get secant, and you get root 58 over 3. The negative symbol belongs in front or in the numerator. And tangent is opposite over adjacent. Opposite is -7, adjacent's -3. Do not leave answers like this, you look dumb. Negative over negative is a positive. Flip it to get cotangent, 3/7. You know a negative over negative is positive. They've been telling you that since 3rd grade. You know it. Stop leaving it like that. Let's see here. That's where I'm stopping. That's enough, because I've got something else I got to do. I got to work on a twin for your test.